Somewhere in a narrow sliver of infrared light that almost nobody had bothered to carefully examine before, a team of astronomers found something sitting on the surface of two completely different worlds, separated by billions of miles, that neither of them should have in common. Not a shared atmosphere, not a shared temperature, not even a shared distance from the sun. Just one identical, precise, currently unidentifiable chemical signature showing up in James Webb's data from both Pluto and Titan, matching absolutely nothing in any laboratory record or planetary spectrum ever published. This isn't speculation dressed up for a headline. It's a real, peer-reviewed finding, accepted for publication in the journal Astronomy and Astrophysics, and as of right now, nobody on the research team studying it can tell you exactly what it is. Let's start with how this was even found, because the story behind the discovery is almost as interesting as the discovery itself. A research team led by planetary scientist Bruno Bizarre, along with 17 collaborators, was combing through James Webb Space Telescope observations of Pluto and Titan, deliberately focusing on a narrow, relatively understudied region of the infrared spectrum, wavelengths that previous instruments simply hadn't examined in this kind of fine detail before. Webb's extraordinary sensitivity made that kind of close examination possible for the first time, splitting incoming light into wavelengths precise enough to reveal subtle chemical fingerprints that earlier telescopes would have missed entirely. As the team compared spectra from both worlds, they noticed something specific and repeatable. A distinct dip in reflected light centered at almost exactly 5.11 micrometers, present in both datasets in essentially the same place. Every molecule leaves behind its own specific signature, written into how it absorbs and reflects light. And identifying unknown compounds across the solar system generally comes down to matching an observed signal against an enormous, decades-deep catalog of known chemical fingerprints, painstakingly built up through laboratory work here on Earth. So the team did exactly that, cross-referencing this newly observed absorption line against every relevant published planetary spectrum they could find. As they put it plainly in their own paper, they did not find any band referenced in that entire body of prior research that corresponded to the exact location of this observed absorption on either Titan or Pluto. In other words, whatever is producing this specific signal has either never been properly identified before or has never been documented, producing exactly this kind of fingerprint under these particular conditions. Here's why finding this same precise signature on both Pluto and Titan is so genuinely strange, rather than simply an interesting coincidence. These two worlds have almost nothing meaningfully in common. Titan is Saturn's largest moon, bigger than the planet Mercury, and famously the only place in the entire solar system besides Earth known to have actual liquid sitting on its surface. Vast lakes and seas made of liquid methane and ethane rather than water. It orbits Saturn, sitting relatively close to the Sun compared to what comes next. Pluto, roughly half of Titan's size, sits about 4 times farther from the Sun than Saturn does. A small, frozen, quiet world with no liquid features at all, drifting through some of the coldest, dimmest space in our entire solar system. Different sizes, different locations, different surface conditions, different overall histories. About the only meaningful thing they genuinely share is an atmosphere built primarily around methane and nitrogen. And yet, somehow, both of them are showing signs of the exact same unidentified surface material. The researchers were able to confirm something else important too, ruling out one of the more obvious potential explanations along the way. By comparing spectra taken from the center of each world's visible disk against spectra taken closer to the outer edge, or limb, where an observer's line of sight passes through considerably more atmospheric haze before reaching the surface, the team found that familiar, well-understood atmospheric absorption lines stayed roughly consistent across both viewing angles, exactly as expected. But the mysterious 5.11 micrometer band behaved completely differently, weakening by roughly half near the limb, where surface light naturally contributes a smaller overall share of what actually reaches the telescope. A feature genuinely produced within the atmosphere itself shouldn't fade in that specific, predictable pattern. This confirmed with real confidence that whatever is producing this signal is sitting directly on the surface of both worlds, not floating somewhere in their atmospheres above it. There's an even stranger wrinkle buried in the Titan-specific data. Webb captured this signal on both Titan's leading hemisphere, the side of the moon that faces forward in the direction of its orbital motion around Saturn, and its trailing hemisphere, the side facing backward. And the researchers noted the band appeared roughly 25% narrower on the leading side compared to the trailing side, though they're careful to flag that comparison as still provisional, given differences in instrument sensitivity and the fact that the two hemispheres were actually observed under somewhat different conditions. If that hemispheric difference holds up under further scrutiny, it would suggest something about the physical process depositing or maintaining this unknown material treats one side of Titan meaningfully differently than the other, a detail that in other contexts on other worlds has sometimes been linked to differences in radiation exposure or particle bombardment between a moon's leading and trailing faces as it orbits its parent planet. The amount of this mystery material also isn't equal on both worlds. Pluto's version of this absorption line came back roughly 3 times thicker than Titan's, and in spectroscopy, a thicker absorption line at the same wavelength generally points toward a greater overall abundance of whatever's producing it. Whatever this substance actually is, there appears to be considerably more of it sitting on Pluto's surface than on Titan's. So what could it actually be? The research team has proposed a handful of genuine candidates worth testing further, though none of them have been confirmed. One leading group of candidates involves alans, a specific family of hydrocarbon compounds, potentially combined with some additional, still unidentified component that shifts their usual expected signature. Other researchers examining the same puzzle have also pointed toward benzene, a ring-shaped hydrocarbon already known to exist in trace amounts elsewhere in the outer solar system, possibly mixed with some other unknown compound, along with the theoretical possibility of frozen acetylene or a compound called ketene ice, both of which behave differently as solids at these extraordinarily low temperatures than they would as ordinary gases. The researchers also took a genuinely useful extra step to help narrow things down. They checked whether this same signature shows up on other cold, methane-rich worlds elsewhere in the outer solar system. Specifically, Neptune's large moon Triton, which shares a broadly similar frozen nitrogen and methane environment with both Pluto and Titan. They found no corresponding 5.11 micrometer feature there at all. That absence is actually a genuinely useful clue, since it suggests whatever produces this material isn't simply a universal byproduct of any cold nitrogen and methane surface, something more specific to the particular conditions on Pluto and Titan and not shared by every similar icy world in the outer solar system, appears to be involved. It's worth being completely clear about exactly where this stands scientifically, because getting that distinction right matters. This is no longer just an unreviewed rumor floating around the internet. The paper describing these findings, first posted to the preprint server Archive back on June 11, 2026, has since been formally accepted for publication in Astronomy and Astrophysics, a genuinely well-regarded, peer-reviewed journal in the field. That acceptance means the underlying methodology and data have now passed a real, independent layer of scientific scrutiny, considerably strengthening the credibility of the finding itself. What still hasn't happened, and what the researchers themselves are completely upfront about, is actually identifying the specific molecule responsible. The detection is confirmed. The identity of what's causing it remains genuinely, officially unknown. So what happens next? There's currently no telescope or laboratory set up on Earth capable of directly sampling either Pluto's or Titan's surface material to settle this definitively. But there is one mission already on the calendar that could eventually provide a real answer. NASA's Dragonfly mission, a nuclear-powered rotorcraft lander specifically designed to fly through Titan's thick atmosphere and set down directly on its surface, is currently planned to launch no earlier than 2028, with an expected arrival at Titan sometime in the mid-2030s. Dragonfly carries its own onboard mass spectrometer, an instrument built specifically to directly identify the chemical composition of whatever it finds when it actually lands, rather than relying on light signatures interpreted from across the solar system. If this mystery substance really is present in meaningful quantities on Titan's surface, Dragonfly may end up being the mission that finally puts a real name to it, and whatever answer it eventually provides could help resolve the matching puzzle on Pluto too. Until then, this stays exactly what it currently officially is: a confirmed, peer-reviewed, precisely measured signal, present in real telescope data, at a wavelength matching absolutely nothing currently cataloged anywhere in planetary science, showing up in different concentrations on 2 of the strangest, most different worlds in our entire solar system. That's not a small or trivial result. It's the kind of unresolved, carefully documented anomaly that, throughout the history of planetary science, has more than once turned out to be the very first sign of something nobody had thought to specifically look for. If stories like this, the ones where the real peer-reviewed science leaves a genuine, honest question mark instead of a neatly wrapped-up answer, are what you come here for, stay close, because there's a mystery sitting on 2 frozen worlds right now, and somewhere out there, waiting on a mission, still years from launch, might be the only way we ever actually solve it.